Hello and welcome back. Today will be a slightly different episode since I will be trying out some test gear. Today's video is sponsored by Digilent and they sent over an ADP2230 for me to test out. This is an all-in-one type of instrument, it contains multiple devices and it's controlled over a USB cable by a PC. So if you're curious about what this thing can do and what it is, then keep watching. Now, the way I first heard about Digilent was through their Analog Discovery product line. I got one of these ages ago and used it quite extensively at the time. I also reviewed this thing in an older video. So anyway, what this is the Analog Discovery 2, which is now discontinued, but there is an Analog Discovery 3. However, the thing that made me get one of these in the first place was that it was the cheapest device I knew about at the time, which could create a Bode plot. So when Digilent reached out to offer the Analog Discovery Pro to test out, I was quite curious to see what they've been up to. What makes the Pro version better than the, well, not Pro version. Now, looking on the Digilent website, we can see that the ADP2230 is part of the Analog Discovery Pro family. So there are 5 devices listed here, a programmable power supply, and 4 multi-tools. So this is a nice comparison table of the main features of each device. And well, if we select the ADP2230, this takes us to its page, well, the 2000 series page, and here there is more focus on the device itself. So you get the list of features, as well as all of the instruments that the device emulates. And if you select any of these, then you also get tutorials to highlight how each instrument works and how it should be configured. Now, while some details may be omitted, this is still a good overview of what the device is. Before looking at the instrument itself, it's important to first check the other half of the story, the part that is critical in any computer-connected device, the software. In this case, the waveforms program. So to get this program, you just need to go to their website, Getting Started, and then go to the product download page. And well, here you just need to create an account and you can download the program. And well, the version you get is the only version. There's no paid or full feature one. Now, even if you don't have a Digilent hardware, you can still try out the various instruments in demo mode. So if there's no device detected, we can simply select a device, and now we can go play around with the various features of the program. So this will highlight the interface and its various features. Anyway, other than the various instruments, we also get a help section, which will highlight the features of each specific instrument, and well, how to set it up. So with that out of the way, let's see what it is that you're getting if you do decide to buy one of these things. Well, you get a box with some stuff inside, like a very brief description, and then you get to the ADP2230 itself. And well, the first thing to notice is just how small but also heavy this thing is. I mean, it feels quite well built. It's not some plastic box that feels all hollow. So looking inside, we see the device, a nice green color, built inside of an aluminum casing. The rear side features a supply jack and the USB-C port, and the front has the waveforms generator output, 2 oscilloscope inputs, and the digital and supply pins, as well as a peel. Now, coming back to the box, if you take it apart a bit, you will find some more goodies. You get your USB cable, 2 standard X10 probes, so these have a switch to select either X1 or X10 mode, and an accessories bag, which importantly also contains these springs. So these are crucial for making low noise measurements. Anyway, other than this, you also get some pins and a cable to access the I/O ports. So one side goes into the ADP and the other into your circuit. You also get some stickers to mark the cables if you want, and a power supply. So this thing is not mandatory, the ADP2230 will work on USB power alone, but if the source computer does not have a capable USB port, then this supply can be used. It's packaged with both a European as well as an American power adapter. And well, we can connect all of the accessories, and this is what we get. You don't always need all of them, but you have them. To test it out, I first created a basic debugging setup, a low power switch mode power supply, which is supplied by the ADP itself. The supply is connected to a resistor load, and the things to look for are the switching node and the output noise. So this will require the spring-loaded tip, and I set the probe to extend mode, and if we look into the switching node, we can see the bandwidth and sample rate limitation. So we can measure a rise and fall time somewhere in the 8 to 12 nanosecond range. Even if the signal is faster, you won't really be able to see it. But regardless, we can use this tool to check for things like ringing and the operating mode. If we now turn to a very small signal, so I put the probe on the supply's output, well, with the probe in extend mode, we can't see much. The ADP device is a bit noisy, so you will not be able to see low levels of noise. If we put the probe in X1 mode, however, the signal becomes more clear. But it's important to remember that with such probes, bandwidth is severely limited in X1 mode. So while we can see the noise now more clearly, it's not necessarily a correct measurement. Another experiment I wanted to perform also refers to making some measurements on a power supply, but it's a bit more hands-off this time. So the tested supply is powered through a power amplifier, which is driven by the waveform generator, and then the two oscilloscope probes are connected to the input and the output, and finally on the output we have both a permanent as well as a switched load, which is controlled by an I/O port. So this is what the setup looks like if you draw it out. So if we now move on to the measurement software, here we can either set a DC or some more complex waveform, for example a 3.6 volt modulated with 100 millivolt sine wave. This, after passing through the amplifier that amplifies it by a factor of roughly 2.2, becomes a roughly 8 and 200 millivolt signal. We can see this on the channel 1 port. And we can now also analyze the output. So for the load, I made a very basic automation to just switch the I/O port on and off, and this leads to a change in load, which we can monitor on the second channel probe. While this is still a very basic setup, you can still automate an entire test sequence, so to set a specific supply, set a specific load, make some measurements, and save. And even if there's no automation going on, you can still save this test setup and then reload it at a later time. Personally, I think this is one of the major advantages of the all-in-one type of instrument, and with the ADP, you can fully take advantage of it. Now, while I did not prepare any specific experiments, it's still important to point out that the ADP2230 is not just an oscilloscope and a waveform generator. You have a few more instruments created using these interface ports. So first of all, you have a spectrum analyzer, so to look at the spectral content of a signal. Then you have a data logger, which can be used to create very long-term measurements, so spanning multiple hours or tens of hours, where the displayed value is something related to the oscilloscope probes. So you can either select some simple functions or a more complex formula. Then we have a network analyzer, which can be used to create things like Bode plots, or well, other things. And you also have an impedance analyzer, which can be used to measure the frequency-dependent complex impedance of a component or device. And then you also have the digital instruments. I have never really used this, but you have them. So you have a logic analyzer, a pattern generator, and a protocol interface in which you can send and receive decoded messages using one of these supported communication protocols. So the help file will usually do a good job of explaining the various instruments. Now, personally, I never really liked PC-controlled devices. I preferred having standalone equipment, something that works by itself, so using its own screen and its own buttons, but there are a few advantages with this tether, especially in the professional workplace. So if you're doing measurements using classical equipment, first of all, it's a large setup. All of the devices need the measuring useful bit, as well as the data processing and screen. So they end up occupying quite a lot of space. Then, if you need to save the measurement, you might also need to use a USB stick or something else. But you still need a computer close by, since you always need to check what you're doing. Maybe you have a schematic, a datasheet, or just your test report. The computer has become central to the modern-day workplace. Now, with the test equipment controlled by the waveform software, well, you have both your measurement and the various instruments, as well as any other supporting information, like datasheets or schematics, all in one screen. Once all the measurement connections have been created, you can do whatever you need from a different interface and not touch the setup anymore. Testing, debugging, and measurement saving are all done in one place. And another nice feature is the ease of saving the program interface. Once you configured all the instruments, you can simply save the workspace and then reload at a later time. Also, having the scripting interface allows for the automation of tests by easily controlling each instrument. If you have some sort of repetitive test going on, well, you can save the test sequence and next time just run the program. And it automatically tests and then saves the results. Now, this of course is not a unique feature. Most modern-day devices do have USB control, setup saving, and can be somehow automated. Strong emphasis on the somehow part. Now, especially if all of your instruments are made by different manufacturers, well, they each have their own interface and control commands, so it's quite a lot of fun to try and learn all of them and to get everything working together. So, is the ADP2230 the solution to all of your problems? Well, it's important to keep in mind the limitations. First, the programmable power supply is capable of delivering a maximum of plus or minus 5 volts at 3 watts. Plenty if you work with a small microcontroller board, but insufficient in most other cases. Also, in the program, there's no proper current indication. If you want to know the consumption, you need some external measuring device. For the analog input, the 50 MHz of bandwidth will be adequate in most cases, especially for measurements where you prefer 20 MHz of bandwidth limit anyway, but it can be quite problematic when measuring certain fast signals. Also, the high noise floor will limit the usability to measure things like supply ripple. But on the other hand, having all the instruments in one place, especially things you might rarely use, is quite nice. And having the possibility to see the results on a full-size monitor, not some tiny device screen, can also be helpful. So there are both positives and negatives if you look for them. Another nice aspect I saw was the Digilent forums, which are quite well maintained. If you need information about the device or its capabilities, the staff will respond in a nice and clear fashion. They will even make comparison measurements, just so you know what it is that you should expect from the device before you purchase it. So this is not something you can say about any manufacturer, so it's quite refreshing to see this. In the end, in my opinion at least, the ADP2230 is an easy to use and to set up, compact device which can occupy very little desk space, so it's perfect for a quick debug session, and you can even automate certain tests with it. But I would not throw away my stack of equipment just yet. Depending on your field of application, it might be able to help with most of the things you need to do, but you will always have niche measurements where you do need a better or a dedicated device. And in other fields, well, it will be more limited. So it all depends on what it is that you would need the device for, if it's appropriate or not for your needs. And with that said, hope you enjoyed this video, and if so, there are more similar videos on my channel that you might want to check out. And if you want to be up to date with my latest releases, also consider subscribing. See you next time. Bye bye.